Bro, you only got like 15 minutes.
Okay.
Since I'm the one that did this, there's a good chance some of these are not right.
What?
No.
No, that's not possible.
Never claimed to be good at math. Here we go. So I'll ask you and see if our answers. Anderson, are you going to talk all the time now? No, sir. So much I can take. Take test tomorrow. Some of you sure want to do. Number one. Number one should be Carter Bocek. I have 1 over 625. Number two, Lucy. Number two, Kavarik.
1 over 600.
Huh?
1 over 600.
It's the same thing, 1 over 625. Yep, 1 over 625. Remember again, negative exponents have nothing to do with whether your answer will be negative. Negative exponents. The reason that one became positive because it was an even exponent of a negative number. Ooh, that was exciting. Number three, Reagan Greider. Now, unfortunately, it's not 33 because you multiply 17 times 16, and it should be 272 z to the 6th over y to the 8th. How many people put 33? I feel your pain like guess what? I did too when I first did it. See? I told you. See? You're looking at a C algebra work right here. Number four, Kelsey Stone. I have 81h to the 20th. People agreeing with me on that? Okay. I will make sure. Number five, Anderson. 4. 5 is 4. 6, Martin. I'm sorry, what? -6 is correct. -6. Number 7, note 7 and 8 did not ask you actually to do the problem. It just said to change the form of the problem. Number 7 was written in radical form. They wanted you to write it in rational with a rational exponent, which means with a fraction. So, David, number 7. I could not hear a word you said other than negative. Yes. Now, the -53 needs to be in parentheses, ladies and gentlemen. If it's not in parentheses, it would not be right. -53 in parentheses to the 4/5 power, because that negative sign has to be taken with the 53, because it's with it under the radical sign. Sam, you seem perplexed.
So you only put the parentheses when it's negative, the base number.
Well, that's the only time it would matter. If the thing under the radical sign is a negative, you have to have the parentheses so that negative goes with it. Otherwise, you would assume that negative sign would be outside of that radical sign. But
if we're positive 53, no parentheses?
You wouldn't have to. No. Number 8, then, LMA Schlody.
-34.
Under the radical sign. Yes?
9. And then parentheses.
Right. It is, actually, you'd say that the 9th root of -34 all to the 4th power. I don't believe you actually need a parenthesis there because I think it would work the same way with or without it, but let's just do it because. Number 9, Emily Robbins.
9.
What? Yes, number 9.
Is 9.
9 is 9. Number 10, Hayden Clark. 1 over 25. Number 11, children. Number 11, when you do said problem, it looks like this. It approaches the y-axis, and it kind of takes a sharp little turn here at 1. It kind of goes. And again, as accurate as you could be there. And it asked you for the domain and the range. The domain would be all real numbers because it goes forever this way and forever that way. However, it does not go forever up. It stops at the y-axis. So the range would be where y is less than 0. It's going to go forever this way, but it can't get above that axis. This would be the asymptote. Doesn't cross it there. That's exciting. Number 12, 13, sorry, God bless you. 13, Lila Francischini. Well, let's worry about 14. Skip the 13. We'll talk about that more later. I'm not as concerned. If you did 13 right, you get 14 right, blah, blah, blah. 14.
468,073.
Yeah, 468,073. There might have been a decimal there, but you can't have 4/10 of a person. So as much as we might hope. Kavarik? Yeah, we'll talk about that later. Somehow. Yes, I think so. I will have to leave Mrs. Stewart a note about that to say you can use a calculator for that and 15. I'm not sure how. What would be a way that you would not be tempted to use it on other ones where you could actually cheat? Not that anybody in here would cheat, but I could just have you write the formula all down there and then have you show me that. Actually, the formula could be more important than you actually knowing how to do it, but you should. Anyways, enough of that. Number 15, how much cash would you have after all of that, David? 15. Translation is what? And 57 cents. Did we say to round it to the nearest dollar? What did it say? 2794.57. 16. Sabring. Translation?
I don't know how to do that.
16, Sam.
X equals 2.
I have x equals -2. 17, Kavarik. That's what I have. 17.2, Avery. You got a 33% chance even of guessing to get this right. Translation? Arithmetic. 18, Liam. Geometric. 19, you should have, the first term is 256, obviously, and then a to the sub n equals a to the sub n minus 1 times 1/2. You could probably put there's a 1/2 in front of it. It doesn't matter. 1/2 in front. 1/2 times a times n sub 1. And number 20, the first term is -3. A sub 1 equals -3. And the thing is a sub n equals a sub n minus 1 minus 3. Minus 3. Questions over answers, Liam?
What is number 17?
-1. LMA Slody. 481h to the 20th power. Lila Francischini.
What was the first 17?
The first 17 problems?
No, there's 2 17s.
What?
Yeah, there is 2 17s.
Oh, the first 17, -1. Again, yeah, I changed that for the real test. In errata, as they say. Yes, LMA? Who? Number 3 is 272 z to the 6th over y to the 8th. Herter Bochek. Really? Kavart? I would love to do number 9. 9? Yeah. Number 9, the answer was 9, as Robbins would tell you. Again, if you want to grab a piece of note, if you have any notes you may or may not want to take on this would be the point of the show. One might duly note, ladies and gentlemen, the thing with square roots or roots is simply that there's not very many numbers that work out, and the book will give you ones that work out just because. So just think that something doesn't work out, you might want to really think hard before you say it doesn't work out. Just remember for problem number 9 here, when you have a fraction, this fraction 2/5, okay, the bottom number is the one that gets put above the radical sign. This is written in rational exponent form, fraction exponent form. When you rewrite it in radical, hence the radical sign, the bottom number is what goes out here. Negative 243, again, because it's in parentheses, it goes down here. If that negative was not in parentheses, if this 243 is not in parentheses, the negative would go out here. And then this whole thing is to the second power. The top number becomes the exponent of that radical. And then here again, you look at this and you think, well, I don't know what times itself 5 times is 243, but you don't have a lot of choices. It really doesn't. You don't want to start with 1 because 1 is going to be everything. But if you had 2s, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. You know, that's pretty small, but because this is exponential growth, if you put 3's in there, believe it or not, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So you end up in the parenthesis with a negative 3. Don't forget, you still have that 2 out there, so you have to square negative 3, and that's where the 9 came from. That is where the 9 came from. Can I do something wrong? All those hands go up. I go like, Lucy? Yes, love to do number 11. Number 11, ladies and gentlemen, is again another one where I tell you do not really overthink it, but do take your time with it. You are just, the only way that we know how to do this, or we're going to do it for right now, I'm sure there's some other way, is you just have to pick your x values and figure out what your y is. You only need 3 or 4 of them, and then you can just kind of get the gist of what the graph looks like. So because you're your own boss, you always want to come up with ones that work out nicely for you. Exponents of 0 and 1 are perfect because they're just easy to work with. If I put a 0 in for x, 3 to the 0 power, 3 to the 0 power is 1. And 1 times anything is itself, so you get that negative 1/3. I would also put a 1 in there because anything to the first power is itself. I'm changing colors because I'm tired of red. So if I put a 1 in for x, I go 3 to the first power, which happens to be 3, and 3 times negative 1/3, the 3's cross off, you're just left with a negative 1. And then you probably want to try, well, let's go a higher number. Let's go 2. Negative 1/3, 3 squared. 3 squared is 9. Negative 1/3 times 9. 3 cross cancels and it gives you a negative 3. And then we might as well go negative and see what happens. Here's where you kind of got to understand your negative exponents. Negative 1/3 to the, and 3 to the negative 1 power. What is 3 to the negative 1 power, Liam?
1/3.
Yes. No, this doesn't make it negative, people. Remember I said that negative exponents don't have anything to do with whether your answer is negative. Okay? You make this positive by putting the 3 under 1, and it becomes 3 to the first power there. So you end up with a negative 1/3 times a positive 1/3, which is a negative 1/9. That's probably enough for you to do it. You take those points, come over to your graph. You say graph, let's do this. 0, negative 3. 0, negative 1/3 is about right there. I missed it a little bit with my thing. 1, negative 1 is right there. 2, negative 3 actually was right here. Oh, it was right here. And then negative 1, negative 1/9. You know, as you keep putting negative things here, you're just going to keep getting closer to this axis, and then you can just kind of grab it like this. Wasn't too bad. I love a parade. Ike. 4. 4 for 4. Oh, Ike. Here is one for the ages, ladies and gentlemen. This would be one I would tell you, you ask 90% of people in the world cannot do this, but it's really easy. Remember, when you have a fraction to a negative exponent, to change that negative exponent to positive, it's just the reciprocal of the fraction, which means you end up with 3h to the 5th over 1, and that becomes to the positive 4th power. Now, I can show you this. It's only logical, Ike, because watch. Well, let me just step aside here. If I actually were to work with a negative exponent, okay, when you have a negative exponent outside of a parenthesis and exponents inside, you multiply those parentheses, those exponents together. So this is what you'd end up with. Well, this is 1 to the 1st power, so that times 4. On top, you'd end up with 1 to the negative 4 power, because I'd multiply those together. Now on the bottom, I would end up with 3. Again, this is a 1 exponent. 1 times 4 is negative 4. And then I'd end up with a h to the 5th to the negative 4 power, which is h to the negative 20th power. Then I need to make all those positive, so then I would switch them from top to bottom, and you'd end up with 3 to the 4th power on top, h to the 20th over 1 to the 4th power. And 1 to the 4th power, 1 times 1 times 1 is going to give you 1. And you're left with 3 to the 4th, which is 9 times 9, 81, h to the 20th. It's much easier just to flip that fraction right away, get rid of the negative, and then work with it from there. You still end up with 3 to the 4th power, h to the 20th, over 1 to the 4th power. Sorry, I didn't mean to go into some long exposition there, but just know to change a negative exponent in a fraction, you just go for it. I'm not even sure Mrs. Galloway would have been able to tell you that. Should I ask her?
Yeah.
This one might be one. I don't know if she would have taught this. Mrs. Galloway,
Yes.
how would you simplify that problem there?
If you, because it's negative, if you flip it and then just to the 4th power.
Oh.
Is that right? And then since you're taking a power to a power, you multiply.
Ooh.
3h to the 20th?
Huh?
3h to the 20th?
You have to take 3 to the 4th power as well. 81.
12h to the 20th.
Oh, no.
Oh, sorry.
Oh.
I'm sorry.
Whoa.
Remember that one stable remover we found? And then
The what?
that stable remover we found?
No, I don't know what happened to that. I said it wasn't mine. I don't think I kept it. I thought you took it because I said I didn't want it. I don't have it.
Happy mathing.
All right. Salome. That one right next to it here? Is that it? Is that it? Oh, yeah. 3 is a good one to talk about, too. Most of this stuff, ladies and gentlemen, is not, it's just not as complicated as it looks. Step number 1, I've said this before. If you see something to the 0 power, if it's got anything next to it, it's just going to go away because anything to the 0 power is 1. If I multiply 17 times 1, I get 17. So this is gone. Then you just need to make the negative exponents positive. There's no alike ones, so you just move them around. So I'm going to move the 4 and the 2 to the top. It's going to be 4 to the positive 2 power. The z to the top is going to become z to the 6th power. And the y is going to go to the bottom and become y to the 8th power. Now, lest you think you're done, you still have this 17 times this 4 squared, which is 16. And yes, I also put 33 when I did it at first, but that was way wrong. I don't know what I was thinking. This is all, there's no adding and subtracting signs here. So this is 17 times 16, which is something. 17, 16, 42, 2, 102, 17, 272 on top with that z to the 6th all over y. Shwapa. Lucy.
For number 12, just explain.
I will go over number 12 again. Everybody seems to have trouble with domains and ranges. I'm guessing that's what it was, wasn't it? Domains and ranges. If I could encourage you, ladies and gentlemen. Domain, which my nephew is in. Those of you that watch Singing in the Rain in here, I told you I went and saw my nephew. He was Gene Kelly in Singing in the Rain in a college production. Incredible.
Okay.
Incredible. Tap danced and did the whole deal. The whole deal.
Whole deal.
You know, you can't, because it's all copyrighted, nobody could make a video of it. It was crazy. It literally was
Is
crazy.
that why we watch Singing in the Rain?
No, I watch Singing in the Rain all the time. The only reason I went to watch it was because we watch Singing in the Rain all the time. Otherwise, I probably would have skipped out on it's a musical. But it was 3 hours long. So think about this. Lucy, you asked me this. Think about when you think about domain. Just to think about what the domain is, think about writing down the points from the graph. Think about points from the graph. Okay, if I asked you, like, what is this point right here, you would tell me that point is 1, -1, correct? If I asked you this point, you would tell me that's 2, -3. Now, if I asked you, well, this point here, it was -1, -1/9, I think. Okay, and then think about it. Domain is what can x be? What can your first numbers be? Is there a limit to what you could have? Could I have x to the 15th, -15th out here? Yeah, it's gonna keep going. Could I have x to the -100th? Yeah, it's whatever. Could I have x to the +6? Now you're gonna say no because this line, but I tell you, this line goes on infinitely. It doesn't matter how straight up it goes. It's never gonna go perfectly straight up. It's always gonna have a little bit of slant. So eventually, given enough time, this line is going to cross that 6 somewhere. It's gonna be some huge, fantastically small y value, but it's gonna go eventually there. It's gonna catch any x number. It goes on forever. It never stops. So the x values are all real numbers. You'll never run out of x values. But, well, it's all real numbers. You could, if you wrote it as infinity, you'd have to go, it goes from -infinity to positive infinity. Just because, and they do that in Yorkville High School. You'll get to that. I can't remember what it's called though. It's got some other name to it. The range, Lucy, are what can y values be? And if you look at our y values, okay, I have a -1, I have a -3, and I have a -1/9. Does y ever keep going up here? No, it never gets to this line. It will never cross the y-axis. So hence, when you write down y has to be anything. It'll go forever down, but it doesn't go forever up. Y has to be anything less than 0. Or you could say y goes, if you were doing it, you would have to say y goes from 0 to -infinity, if you're in fact talking about infinity. And they do that in something. I suppose you'd do it like this, y goes from less than infinity to... Can you have equal to infinity? You could never get to infinity, could you? Buzz Lightyear, to infinity and beyond. Kavarik has a great question for us.
For number 8, when you rewrite a graph form, do you want to put parentheses inside too?
No idea what that question
Put
is.
word that you could do that.
Somebody answered it for me though. Again, you don't need, if you're writing from radical to rational, you just need this. There's no parenthesis because this radical sign is a grouping symbol, so it really is the parenthesis that you're using. And then the bottom number is the 9. And yeah, I would say that's the parenthesis you want. Yeah, I'd put that in parentheses. I don't think it matters because you have to simplify the radical before you do that anyway, so that parentheses really is not gonna change anything.
So if you don't let it open up.
Yeah, I'm pretty sure I would let you, as a matter of fact, children, I'd be willing to bet it doesn't matter which of these two you do first. In other words, I'd be willing to bet that if you took negative 34 to the fourth power and took the ninth root of it, you'll get the same thing as if you take the ninth root of negative 34 and then take it to the fourth power. I believe powers and exponents fall in the same order of operations, and I don't think it matters because they're operations that undo each other.
We should test that theory.
Let's take it out, let's do it. I want you to take negative 34 to the fourth power, then take the ninth root of that. What did we get for an answer? It was, wait, what was? Oh, this didn't work, this doesn't work out evenly, but you'll still be able to give me a decimal equivalent somehow. It won't work out evenly, because there is no ninth root of negative 34 or whatever it is. Oh, maybe it does work out. Well, no, it doesn't, because you can't get. While he's testing that theory there, Avery, is that I was hoping to do some of the really mathematical formula stuff, because those are some of my favorite stuff. I'm not a big fan of the sequence formulas, just so you know. Yeah, we need to talk about 17. You need to take some notes on 17, just so you know. If you didn't get them, then you don't get it. But just know this, Riley, and whoever, if you're out there in whatever land here, okay, you want to know when these things are equal, and you've already got the same number base. So if you could get the same number base to have the same number exponent, they're going to be equal, and that's what you're doing. If you have the same number base there, you need to just make this equal this. 8x has to equal 5x minus 6. If you get whatever number that is, if you get that to be the exponent, then they're going to be equal. So you just need to solve this by subtracting 5x. You get 3x equals negative 6, divide by 3, divide by 3, x equals negative 2. Now we can test that. Why? Because if I put negative 2 in for x, 8 times negative 2 is negative 16. If I put negative 2 in for x, 5 times negative 2 is negative 10 minus 6 is negative 16. 3 to the negative 16th power by all means will equal 3 to the negative 16th power. They're equal. Now the problem we run into is this. You can't do that with this. I can't make this equal this because these aren't the same. So your problem, your challenge is to somehow figure out how to make the same base. And remember, we did do this when we couldn't do the same base, but we had to use the Chromebooks. That's when we went to Desmos, remember, and you type this in as an equation, type that in as an equation, and saw where the lines equal this, equal to that, or whatever it was there, wasn't it? Yeah. Now, so the question is that, fortunately for you, Sam, they will make problems that do. If you look at 25 and 125, they have a common, I don't know if I want to say factor, but I guess they do have a common factor. What number, when you take it to an exponent, gives you 25, and that same number, when you take it to an exponent, will give you that, 5, right? And this 25 is 5 squared, and 125 is 5 to the third power. Okay? So now those would be the same bases. But in order to do that, you have to take that exponent that you put here, and you have to put this in parentheses next to it and multiply it by that. And the same thing here. Whatever your exponent is, you have to take the old exponent and multiply it by that. And then, once you get it to that point, you can take this and make it equal that, and you get some sort of. Matter of fact, tomorrow, when Mrs. Stewart is here, she's going to want to take this test. I'd be very impressed if she can do all of these problems. I'd be overwhelmingly impressed, actually. She might be able to, because Stewart's are good at math. 2x minus 4. All of their whole family goes to the University of Illinois. If you don't know anything about the University of Illinois, it is not an easy, you don't just apply to the University of Illinois and get into the University of Illinois. That's like, you have to be somewhere up there in the stratosphere smart. Boom. So you end up with that, and then just solve that. Did you ever come up with a conclusion here? 7x, subtract 3 from this, 7x equals -7, so x equals -1. Liam may want to try this. If I put -1 in for x here, is 25 to the -3 power equal to 125 to the -2 power? God bless you. I'm going to guess it is. Is 1/25 squared equal to 1/125 to the second power? I can guarantee it is just by looking at it, simply because one of these was 3. This was a 3. That's neither here nor there. We won't have a technology one. Ooh, it's crazy. No, if I didn't give you one on the pretest, I'm not gonna put it on the test. Where? There's one where you had to use the Chromebook?
Yeah.
It's,
Yeah, but it wasn't one of these though, was it? It wasn't one where you had bases, equal bases. No. I was just saying. Which one? There's no 14 here. There's no 14.
I pushed it out a little bit.
Go right
There's no 14.
Right up.
One more up.
Up. Nope.
There you go.
Hey.
Oh, the population? Oh, yeah, well, that one. Yeah, no, yeah, this one, but this one isn't a base thing. Do you want me to do this one by chance? Yeah, you will. You can't do this one. This one is based on the formula where, what type of growth is it? It's that growth and decay. It's growing there. What was the formula? I think it was, where is it? A sub n equals what? Who? B.
P.
P.
Like
Right.
I was gonna say, it was, in the book, it was listed as A.
It's Y.
It's whatever the initial, it's the initial number. Times what? 1 plus r to the t or x. Time or x, either way. I think the book gave it as x, but in this case, x is the t. So in your notes, the letter A is whatever you start with, which was this was 315,000. I'm taking 315,000, multiplying it by, what was the rate of growth? 2%? This was 2%, but you need to make it a decimal, so it's 0.02. So 1.02, and then how many years was it? 20 years. Went from 2010 to 2030. So, shebang. Will the little calculators do that? No. You know, there's no exponent. Do I have to go any farther? So you have to do this first. 20th power, 20th exponent 1.02, which isn't a very big number. It's like 1 point. Yeah, I'll let you use it. I'll tell him. Remind me to tell him this is super. What?
What was the answer between?
Number 20, A, the first term is -3, and you get A sub n equals A sub n minus 1 minus 3. Did I not do that right?
Wouldn't the first term be 0?
It should be. The first term should be 0. I just said that to make sure somebody was paying attention. Yeah. And then A sub any term would be the A sub n minus 1, the term in front of it, minus 3. So the term in front of this would be 0, 0 minus 3 is minus 3. The term in front of this is negative 3. So you just keep subtracting through it. No, LMA, what?
Wait, that one, because it's explicit, so you have to put the first term, that's also.
Ooh, that is the recursive rule, isn't it? Isn't that the recursive rule?
Yes, because you need the first term first.
Stop me here, people. The explicit form of arithmetic needs to be in this one. See, LMA has got, wait, where is it? This is how that should look. Who did not stop me again? I'm just checking to see if you're all on the same page here. I'm gonna copy this. Did not anybody have this? Somebody say yes.
Yeah.
You didn't have it or you did? See, people, you gotta learn to speak up. If you have an issue, speak up. People, 'cause- where is it? I gotta go here. We're gonna paste it in here. That's why I gave you that silly formula. We need our formula to look like this. So a sub 1 was the 0, which isn't gonna change anything. Plus, what term were we looking for? We don't know. And minus 1 times, what was the common difference? Negative 3. So that's what it should look like. And that's what a sub n equaled. So you just do the distributive property. The answer for that should be this, children. Negative 3n plus 3. This is what number 20 should have been. Did anybody have that? Did you have help with it, though? Did you do that? See, you guys are way above what I am there. So make sure in your notes you have this written down for number 20, because I'm sure it's the same. Although it might be, I'd put both of them because it might be actually a geometric one. Is that going to cause you trouble? Somebody say yes or no. We're crying out loud.
Yes.
The geometric one would just be this. It's just the first term times the rate times n minus 1. So wait, here, let's do this. Just to give you a heads up. Ready? Ready? Get set. Ready? Ready? Just to help you out. Let's just say I asked you for problem number 19 for the explicit rule.
Wait, you don't mix up. These are not 20. You use the
Wait, I just wrote it over here, if that's what you're doing. I was supposed to do the explicit rule over here.
yeah. And the explicit rule is times 2, not plus 2.
Can also be divided.
Wait, what are you talking about?
It's times 2.
No, he
Stop,
was
stop, stop. Yeah,
He
I put the
did
D,
the
right here
distributive
was the D. It times that N with negative 3, and that times that times that gives you
distributive
negative.
property.
Now, don't worry. As Einstein, I know your problems, his was even worse. So if you were asked to write the explicit rule for this one, you just take a sub 1, which is right there, 256, and you're multiplying it by what was, how are you going from this one to this one? You are times 1/2 to the n minus 1. Now, let me ask you a question. That would be the rule, a sub n. Couldn't I just take 256 times 1/2, write that down, and take that to the n minus 1? Yes or no?
Yes.
Yes or no?
No.
No. Why not? Somebody tell me. Somebody tell me why I couldn't take half of this and put that to the n minus 1 power. There's a very good
It's
reason.
in parentheses.
It's written on the wall. Not there. Oh, yes, it is. No. Oh, I guess it isn't written on the wall. Yes, it is.
on the wall.
No, it isn't. Wait, maybe it is. No.
Right.
Just write it.
Why is it? Why can't you do this? Because order of operations say you have to do exponents before multiplication. Please excuse my dear Sally. Parentheses, exponents, you have to do this before you do this. It's a given. It's a have to. Who is more confused now than when they first came? David, you can't say that. Yeah, liars, all of you. Wait, you have another question?
Yeah.
Who? Didn't I do that already? Oh, well, ooh, yeah. You make sure you have that formula there. For what? What was the first number there? Y. Principal times 1 plus the rate divided by the n times the n times t. Now, on this one, ladies and gentlemen, we didn't have to worry about the n because it was already compounded once a year. I am going to do you a favor and tell you what it is compounded on the other one, Jessica, as well. I think it was 4. What is it? On the real test, don't tell anybody, but it is compounded monthly, sorry.
Monthly.
So it'd be 12 times. Your n is going to be 12. Every one of these is going to be 12. I don't know what the rate is, but you're going to have to put a 12 here and a 12 there. Wait, do I have to do the rest of that? What?
No.
I know, but on the real test, it says monthly.
Oh, very good.
Would we be able to use?
Yes, you have to. You wouldn't even be able to do this one without a calculator. What?
What was the actual answer to number 19?
You don't have to solve it, right?
I had the right answer for 19.
Yeah, you don't have to solve it.
Different thing.
What?
Because it says do the recursive related.
Oh, the one I did up here, I said just in case they asked you that.
Yeah,
The recursive one is a to the n minus 1 times 1/2. It would be this. Or we put it in front, 1/2 of a to the n minus 1. Or just 1/2 of a, you don't need a parentheses, it's 1/2 a n minus 1. Because it's whatever the term in front of it is. This one's going to be an exciting one. Who's excited about this? Those of you that are leaving early, which would be Kelsey, Spring, and Lucy,
What are
and
the
Emily.
games tomorrow?
I'm going to have Mrs. Stewart give it to you at the beginning of geography, at the beginning of that. So you have time to do it then. And, huh? 10:30? 10? Some people do, not our girls. Are you kidding me? They wouldn't do that. Mike's gonna hand out your test though.
What seat are they? Are they the sixth?
They're the 4 seed, right? Liam, did you like what Lucas
Five
did to your
seed, they're
finger?
five.
We're literally cheap on a whole nother level. We're underdogs.
We should be like 5.
I'd rather be 6.
Well, listen, you guys are obviously one today. Like, nobody's reading this.
We got
You got some. They're winning now. Maybe number 1 too. It's like for what?
No, they beat both of the teams.